Hi, everybody. Welcome to my channel, Numbers with Nora. This is a math tutoring channel that helps you with all your math questions, homeworks, and needs. For this specific video, we're going to be doing geometry, and I got this from a student. Shout out to Donia. This is going to be chapter 7 for geometry, a practice test from out of the book that she is using. If you don't have that book, that's okay. If you have questions on it, always leave in the comments below. And yeah, let's go ahead and get started. So this is mostly going to be on quadrilaterals and parallelograms. The first thing before I start doing 1 through 3, we're going to come back to this a lot. It's basically the characteristics of a parallelogram, how to tell if something is a parallelogram. You're going to look at these 4 characteristics. 1 is that opposite sides are congruent, aka equal. 2, opposite angles are congruent. 3, the sum of interior angles is equal to 360. And then 4, consecutive angles, basically angles one after another, are equal to 180, or they're supplementary, okay? So you want to keep these things in mind when we're thinking of parallelograms. Okay, so let's go ahead and tackle 1 through 3. This one, find the value of each variable in the parallelogram. So they already gave us that they're parallelograms, so we can use those 4 statements that I set up there. Also, another characteristic of parallelograms, if they do have middle segments, this is going to create a mid-segment, and by definition of a mixed segment, it cuts these into 2 congruent parts. So for S, we're going to get it's equal to 3.5. Okay. Same thing for here. Cuts it into 2 congruent parts. So for R, it's going to be equal to 6. Okay. Now let's look at 2 for 2. Now remember I said the opposite angles are congruent for a parallelogram. So that means that these 2 angles are opposite. They're going to be congruent. So B is going to be equal to 101 degrees. And then I'm going to use another one. Consecutive angles are supplementary or equal to 180. Consecutive angles are ones that touch or hit, like, are one after another, right? So I could set this up like A plus B, which B is 101. So I'll use substitution to put that there. I'll put degrees. Equals to 180 because they're supplementary. Okay. Now all I have to do is subtract 101 from both sides. I'm going to get A equals 79 degrees. Okay. And you can check your answer by making sure that this angle and this angle will equal 79 degrees. Add up all your interior angles. You should get that all of them add up to 360, which they do. So this is the correct answer. Now let's go ahead and look at 3. Remember, opposite sides of a parallelogram are congruent. So P is going to be equal to 5. And to find this one right here, we're going to set up an equation because these 2 sides are congruent. So the equation that we're going to set up is going to be 6 equals Q minus 3. I want to solve for Q, so I'm going to add 3 to both sides. I always like writing my variable on the left-hand side. So 6 plus 3, I'm going to get 9. And you can always check your answer by plugging it in here. 9 minus 3 is going to be 6. Both of these sides are congruent because both of them equal to 6, so that's correct. Right? So let's go ahead and hop on down to 4, 5, and 6. For this one, it says, given the most specific name for the quadrilateral, explain your reasoning. All right, so there's going to be different types of quadrilaterals, and I will show you those types right now. You guys can go ahead and put this one in your notes or take a screenshot and put it in your notes because it's very useful. So you can sit there and it helps you memorize them or kind of understand what they are. So we have a rectangle, square, rhombus, parallelogram, trapezoid, and a kite. And then in blue, it says their characteristics and why they are such a quadrilateral, okay? So I'm going to use this chart to help me solve 4 through 6. So 4, if I notice I have 2 right angles, right? Also, if I sit there and connect these right here, I end up with I end up with 2 parallel opposite lines, right? It's supposed to hit right there, but we get the point. So if I sit there and want to look at a quadrilateral that has at least 2 right angles and then has opposite 2 sides that are parallel, it's going to be this one right here, a trapezoid. Okay. So 4 is going to be a trapezoid. I'll just put trap for now. Let me make sure this doesn't kick me out yet. Okay, it hasn't. All right, so let's go ahead and look at 5. For 5, I noticed that my touching sides right here are congruent. And the same thing goes for these sides. My touching sides right here are congruent. And I also have one right angle. So the quadrilateral that looks like that is going to be a kite, okay? Because my adjacent pairs of sides are equal, which is exactly what's happening. So this is a kite. A-I-T-E. And then let's go ahead and look at 6. Now for 6, I'm going to sit there and use our side angle side or side side side, which is our postulates. If you forgot about our triangle postulates, go back and look at my videos for chapter 4. Okay. So I'm going to sit there and cut this into 2 triangles. And that way, if I could show postulates, I could sit there and start marking up my sides and saying they're congruent. Okay. So once I create this triangle, I have this triangle, that triangle. I know these sides are congruent because that's reflexive property. I also know that these angles are congruent because they mark those up for us. So I can say these 2 triangles are congruent by angle, side, angle, which is one of our postulates. Angle, side, angle. Since I sat there and proved the postulates, I sat there and proved that these 2 triangles are congruent. Since they're congruent, they have corresponding sides that are congruent, okay? So I can sit there and say that this side corresponds with this side, and I can say this side corresponds with this side. Since I have corresponding sides that are congruent, let's go down to see which quadrilateral this is going to be. Make sure this isn't kicking me out yet. Okay. This one is going to be a parallelogram. Opposite sides parallel and equal. I can't really say anything about their oh, I can. Their opposite angles are congruent as well. So this is going to be a parallelogram. Okay. Parallelogram because their opposite sides are equal. Let's put parallel. Okay. It's a parallelogram. Any questions on 4 through 6, go ahead and put in the comments. I'll happily answer them. All right, let's look at 7. For this one, I always love to annotate. So in a convex octagon, I'll go over what convex means in a second. 3 of the exterior angles each have a measure of x. I'm annotating because all this information I'm going to use. 5 exterior angles each have a measure of 2x plus 7 with a total because the octagon has 8 interior angles, okay? So what they want us to do is they want us to sit there and find the measure of each exterior angle, and we can do that. All right. So in order to do that, first, I want to look at the definition of concave. Any polygon that's concave means that its interior angles, their measures are less than 180 degrees, okay? Oh, let me just a second. Sorry about that. Okay, so it means that their interior angles are less than 180 degrees, all right? And so octagon, that's just going to be 8 sides, and we do have 8 sides because they say 3 of them are equal to x, and the other 5 are equal to 2x plus 7. Now, to find all the exterior angles, we know that when we sit there and add the exterior angles of a convex polygon, they're going to be equal to 360 degrees. So I'm going to sit there and try to write up a mathematical equation or an algebraic equation that will help me solve this. So I know if I sit there and add up all my exterior angles, they'll be equal to this. So instead of doing x plus x plus x, I can write 3x. And then I have to add in my other 5 angles, right? And instead of doing 2x plus 7 plus 2x plus 7 plus 2x plus 7 plus 2x plus 7 plus 2x plus 7, I can totally sit there and multiply it by 5, 2x plus 7 times. Okay. Way better equation than writing it all out like that. Now I just use algebra to solve and solve for x, right? So let's start first with just distributing. So when I distribute, I get 3x plus 10x plus 35 equals 360. 360. Okay. And now I want to sit there and combine like terms. Now I get 13x equals, I'm going to go ahead and subtract that 35 from both sides. And when I subtract that 35 from both sides, I'm going to go ahead, excuse me, get 325. Now I divide both sides by 13. 325 divided by 13, I'm going to get x equals 25. Okay, so one of the answers, I'm going to have 3 of my sides equal to 25, but then 5 of my sides are going to be equal to, I'm just going to plug it in here, because right here, right, 25 plus 7. When you sit there and break that down, that's going to be equal to 57. And don't forget your degrees. Okay. So that means 3 of my sides are going to be, or 3 of my exterior angles are going to be equal to 25, and the other 5 of my octagon, they're going to be equal to 57 degrees. Okay. Now let's go ahead and look at 8. I'm going to go ahead and erase this because I know I'm going to need some room. For 8, quadrilateral PQRS has vertices. Let's kind of like sketch something out so we know what it kind of looks like. So we have P, Q, and then R and S. And they give me what their coordinate points are. Classify quadrilateral PQRS using the most specific name. So we want to sit there and see if my sides are congruent. And then also we can sit there and observe if my mid segments are congruent, because if they are, that means that where they touch inside of my quadrilateral, they'll form a 90-degree angle. Excuse me, I don't know why my nose is getting stuffed up. All right, so let's go ahead and see what sides are congruent. And for this one, we're going to use the distance formula. And I'll write out the distance formula right here just in case you forgot it. So the distance formula is actually going to be square root. You take x sub 2 and subtract it from your x sub 1. And then you square it. And then you're going to add that to y sub 2 minus your y sub 1. And you square that. Okay. And that's all under square root. So let's do that for all our sides. Let's start with PQ. I'll do PQ and I'll do SR. The other ones I'll let you do, but I'll give you a hint what they are. Okay. So how I'm going to do PQ, right? I'm going to set this up. So my P, my X sub, I'll use Q as my, I'll use 9 as my X sub 2. So I have 9 minus 5. 9 minus 5. All right. If you have to sit there and like annotate as well, for those of you who aren't really strong with coordinate points, that's fine. You could annotate if you have to. Okay, like I did with this one, just so you guys can know y sub 2. So x sub 2 minus x sub 1, right, squared. And then plus my y sub 2, which is 6, minus my sub 1, which is 1, squared. Okay. And now I work that down. When I work that down, 9 minus 5, that's going to equal 4. 4 squared is 16. So that's 16 plus 25, because 6 minus 1 is 5. 5 squared is 25, all right? And it's for this one, you're going to get the square root of 41. All right, and you want to sit there and do that for each one. I'm just going to do SR really quick, and then PS and QR will give you the answers, but you should try to work about by yourself as well. Okay. So for SR, I'll use S as my X sub 2 and Y sub 2. So I'll have 1 minus 5 squared plus 6 minus 11 squared squared. Okay. All right, so that's going to equal 1 minus 5 is negative 4. Negative 4 squared is 16. And then plus 11 minus 6 is negative 5. Negative 5 squared is 25. So again, this is going to equal square root of 41. So that shows that at least these two sides are parallel. All right. And it's up to you guys, for you guys to find P and S and Q and R. Just as a spoiler alert, those are also equal to 41. So that sits there and means that all my sides are congruent. All right. So since all my sides are congruent, that means that this can either be it can either be all equal sides. It can either be a rhombus or a square. Okay. But to figure out if it's a rhombus or square, I need to sit there and see if my mid lengths are congruent as well. If they're congruent, then that means that they form a 90-degree angle and this is a square. All right. So how you would check that, I'm going to go ahead and erase this. I'll do the mid section in the green. Oh, excuse me. So how you would check that is you want to sit there and check the distance between P and R and Q and S, okay? So P and R. All right. And again, you're just using the distance formula for that. So the distance formula for that, and I'll just set up the distance formula so you guys can see these ones. It's going to be 5 minus 5, because P and R, right? So 5 minus 5. 5 minus 5 squared plus 11 minus 1. And that's squared. When you sit there and use algebra and solve this down, you're going to get PR is actually equal to 10. And then if you do SQ or QS, it doesn't matter. I'll just put into QS for now. Square root. You'll get 9 minus 1. squared plus plus 6 minus 6 squared. Do the algebra on that. All you're going to get is, what do we get? That's 8 squared, square root of 64. You're not going to get 10, okay? Square root 64. Right, squared. So these are not going to be equal. So that means we're just going to have a rhombus, okay? Okay, this is just going to be a rhombus. And we prove that with using the distance formula and find the distance between our midpoint, our mid lengths, and all of our sides. Okay. If you have any questions on this one, let me know as usual. Now let's go down. I think I have time to look at 9 through 11. Let's try to see if we can get through these. Determine whether enough information is given to show the quadrilateral is a parallelogram. Explain your reasoning. To look at 9, I would say yes, because if I sit there and again use my postulates, I could sit there and say these are vertical angles. All right, vertical angles are congruent. I could say by angle, side, angle, that these two triangles, AEB and DEC, are congruent, so they have corresponding sides. So I could say that this side are congruent, and I can also say that for these two as well, using the same thing and the same reasoning. Okay. So I could sit there and say that this quadrilateral is a parallelogram. And remember, a parallelogram has to have those 4 conditions that I stated in the beginning of this video. Okay. The opposite sides are congruent. Opposite angles are congruent. The sum of their interior angles are 360 and consecutive angles are 180 degrees. Okay. It has to go. So I could sit there and say this quadrilateral is a parallelogram because my opposite sides are congruent. Okay. So for 10, again, I'm going to sit there and use the postulates. If I look at these as 2 separate triangles, these 2 sides are congruent because of reflexive. These 2 sides are congruent because they gave it to us. If I look at these, since they're congruent and it is a quadrilateral, so I can say they're parallel, I can look at this as a transversal and sit there and see that these 2 angles right here are alternate interior angles. So that means by side, angle, side, again, a postulates, I can say the corresponding sides are congruent. Okay, so now I could sit there and say that these are, so it shows that this quadrilateral, indeed, I could say it's a parallelogram, okay? Because I use the postulates side, angle, side, okay? For this one, W and X, if I sit there and say that these opposite sides are congruent, this is 60. If I sit there and add all these up, 120 plus 120 plus 60 plus 60, that will equal to 360. And again, like I said, with our postulates, with our rules for a parallelogram, the sum of our interior angles are going to be equal to 360 degrees. So this classifies as a parallelogram. So yes, for 11 as well. All right, for 12, I'll try to walk through 12 and 13 as fast as possible because I'm running out of time. So explain why a parallelogram with one right angle must be a triangle. A parallelogram with one right angle must be a triangle. So if we sit there and go like this, and it has one right angle, well, all the rest of the angles have to be right angles as well because all the interior angles have to add up to 360, right? So the only way I'm going to get them to add up to 360 is I have to sit there and make sure they all equal 90 because 360 divided by 4 is going to equal 90. So if one of my interior angles is 90, that means all of them have to be 90, okay? So that's kind of like an explanation for 12. This one summarizes the ways you can prove that a quadrilateral is a square. One way you can prove it is a square is proving that all your sides are congruent or equal, kind of like what we did in number, I believe it was 8. And then we can also show it's a square by showing that the midsections are congruent, okay? Because if the midsections are congruent, that means they're going to form a 90-degree angle, okay? This is kind of summarizing what we were doing in the one previously with number 8. All right, so 14, you're building a plant stand with 3 equal speed circle shelves. The diagram shows a vertical cross section through the diameters of the shelves. What is the diameter of the middle shelf? All right, so this one comes back from an old theorem that we sat there and went through. So if I look at this as my base right here, and this is kind of like a triangle kind of thing, my base, that means my middle part is always going to be half of my base. All right, so half of 15 is going to be 7.5, I believe. So x is going to equal to 7.5 or 7.2. Half of 15 is going to be, why am I drawing a blank right now, guys? This is what happens when you do math all day long. All right, 15 divided by 2, guys. 7.5. I was right. I was second guessing myself. 7.5. All right. So x is actually going to be 7.5, and that comes from an old theorem. When you're finding the middle of a triangle, it's going to be half your base. Okay. That's all the time that I have for this. If you have any questions or anything, let me know. You can always leave a comment. And if you would like further tutoring, please subscribe or leave a message, like I said, in the comments. Thanks, you guys.